part. Yeah, so satisfying. All right, thanks everyone for coming to seminar today. So it's my pleasure to introduce our seminar speaker, so Cynthia Catton. So she's visiting us from the Bodega Marine Lab, where she has a joint appointment with California Department of Fish and Wildlife and the Bodega Marine Lab, so she's an environmental scientist and a research associate. A little bit about her academic background. So she did her undergraduate degree at the University of Washington. She spent some time playing around in Puget Sound and doing some research there, looking at the effects of salinity on larval distributions of invertebrates. Then she did her PhD down at the Scripps Institution of Oceanography in San Diego. She worked with Paul Dayton and Jim Lecter. She was working in kelp forests, both in Southern California and Northern California, studying population dynamics of pink abalone and red abalone and wavy turban snails. After that, then she did a postdoc at the Southwest Fisheries Science Center in San Diego. And she continued working on population dynamics of abalone, but this time black abalone, and involving a lot more sort of modeling and other quantitative skills. Looked at the same time, she also started working on white abalone. So she's just working her way down the line, ticking the boxes every abalone. Then after that, then she moved up to this position at Bodega and with Fish and Wildlife. And since then, she's been continuing a lot of research studying fisheries for key invertebrate species, abalone, urchins, up there, conservation issues, and really doing a lot of work trying to understand some of the dramatic changes that have happened to the kelp forests up in Northern California due to climate change, heat waves, diseases of sea stars. It's double, triple whammy, everything that's happening and kind of some of these crazy changes and what some of the implications are, and then how you might restore and what you can do to kind of affect some changes. And that's what she's going to be talking about in her seminar today. So yeah, with that, Cynthia, she'll be telling us about guiding kelp restoration actions in Northern California through multidisciplinary science and community engagement. So let's welcome our speaker.
Thanks, Scott. Well, it's a real pleasure to be here today. This is not my first time here at the Moss Landing Marine Labs, but it's one of my first times, and it's just such a gorgeous campus. So I really appreciate the invitation to be able to come down here and share with you some of my thoughts. As Scott mentioned, I'm going to be talking about the large-scale loss of kelp forests that we've been seeing on the Northern California coast, and I know some of you guys have witnessed that down here as well. Really taking a step back and thinking about these major climate change impacts that we're seeing recently, some very tangible examples of multiple stressors operating in our systems to really catastrophic ends. And thinking about what do we need to do moving forward, what do we need to think about, and how do we need to change our strategy so that we are able to address not just the ecological consequences, but also the social consequences. How can we marry those and really have a positive outcome out of this? So before I get too far down the road, I wanted to give a shout out to my colleagues at the Bodega Marine Lab and up in Fort Bragg. These are the core marine invertebrate management team that works in the kelp forest with me. And our job is really to do the science. Sometimes it's long-term monitoring, just kind of trudging along and counting and measuring things in interesting ways. And sometimes it's really much more cutting edge, thinking about those future potential impacts that we need to be ready for and have a response to, a management response to it. And if you guys want to learn more about what we do and how that works, we often have two COAST interns, and that is an opportunity that's available to any Cal State University student, undergrad or master's student, and we've had both, and they've been lovely and really, I think it's a very mutually beneficial program. So I recommend that you guys look into that because it's really a fantastic option. So I realized that it's the Fish Lab that is hosting me, but I'm going to do a little bit of invert boosting. this is a bit of mind blower, I think. So this is a graph that's adapted from a paper that my colleagues published in 2014, showing how the value of commercial fisheries has been changing. There's been a massive shift in the taxonomic group that is really driving the most value in our commercial fisheries over time. As the finfish fisheries have been collapsing, the invertebrate fisheries have really been picking up a lot of that slack. So, so that's part of my drive, is to make sure that we're able to manage many of those emerging fisheries or really high value fisheries that we have a tendency to overfish because they're high value. And many of those invertebrate fisheries are dependent on healthy kelp forests. So we're talking about urchins and lobsters. I have a fish in there. And sea cucumbers. The abalone fishery is not a commercial fishery anymore, but it was a very high value recreational fishery in Northern California. And I just wanted to point out the commercial urchin fishery. This is a graph. You can go onto the landings data that are online and see which fishery is the top fisheries by value. And in the last couple of decades, 4 out of the 5 of the top 5 fisheries have been invertebrate species. The red urchin has been one of them for a very long time. And what this fishery is, the red urchin is the larger of the 2 species. I have this other, these guys down here just to remind me to tell you that there is another species of urchin that's smaller. It's the purple urchin. There is a small fishery for purple urchins, but mostly they're targeting red urchins. And the fishery product from that is the reproductive tissue of the urchin, which is uni in sushi restaurants. So this is one of our major players here. And I'm going to be focusing on the kelp forest that is north of San Francisco, which is dominated by bull kelp rather than giant kelp, where you guys have a combination of giant and bull kelp here. Mostly we just have bull kelp. And mostly that bull kelp is really along a 250-kilometer stretch of coastline where that blue line is. And I just want to point out that we have had a very long-term, robust, not terribly variable kelp forest growing off the coast of Northern California, despite the fact that we haven't had sea otters. So I just want to point that out because I know we're surrounded by them now, right here in particular. And so out of any group of people that I'm going to be talking to, you guys are probably thinking, well, what about the sea otters? So we don't have sea otters largely up on the north coast. They do pop up there every once in a while, but they don't stick around. They come back down here. But we have had, for over 100 years, reasonable kelp forest despite their lack. So that's something to keep in the back of your mind. we now are switching over to an urchin barren condition, but it's not just because the sea otters aren't there. And just give you a little bit more background. So we're zeroing in on that part of the map that I'm talking about, that more than 250 kilometers of coastline. And if we look at the historic maximum canopy extent of the bull kelp, almost 95% of that was growing off 2 counties, Sonoma and Mendocino County. Bodega Bay, where I work, is just on the kind of the southern end of Sonoma County, that bright red county down there. So that was the heart of our bull kelp forest. It was the heart of our abalone fishery. It was the heart of our urchin fishery. And this is what it would look like if you were diving in the bull kelp forest, where all of the biomass, most of the biomass is up at the surface, where we could see it from an aerial survey. So we've been surveying the coast with airplane-based surveys for about 20 years, not every year, but periodically throughout that time. So we can see how does the recent growth relate to what we would expect from the past. And as of 2014, we were seeing less than 5% of what we should be seeing, especially in that Sonoma-Mendocino County coastline. So I'll just let you sit with that for a second. That's a huge loss over a very large area. What that looks like from the surface, normally we would see, like I said, the blades at the surface and the tops of the bull kelp, like this picture in 2012, that same area. I traveled all around that area with a boat. I could not find any. So that's what it looked like from the surface. From underwater, there's been dramatic shifts, not just in the canopy, but also sub-canopy and at the reef itself. So I'll get more into how did we get there, and what are the consequences. One of the reasons we know what happened is because we've been monitoring this coastline for about 20 years, not just from the air, but from underwater as well. And so we have long-term monitoring program that we have a lot of volunteer AAUS divers coming out and diving with us. So if you are a scientific diver, you're welcome to contact me and join us. We're always looking for good people to come and help out and do a little extra work. If you have something specific to a question you want to ask, come talk to us. So that this is really critical information to help us understand what would we be expecting out of this system, how is it different now, and because we're monitoring not just at our fish sites, like our abalone fish sites, but also in the MPAs, we can detect whether the changes are due to overfishing or an environmental factor. So what we've been seeing in since 2014 is the consequences, the culmination of a series of multiple stressors that are both ecological and environmental stressors to the system, and included toxic algal bloom in 2011 that hit part of the coastline. It included the massive scale sea star wasting syndrome that hit all the sea star species from Baja up to Alaska at varying times. It included persistent warm water conditions from multiple sources, whether it was the warm blob up in Alaska, the marine heat wave, or and the El Nino condition that hit us starting from the south. Northern California was right in the middle of those two forces. And the consequence of that has been this massive shift away from an urchin, a kelp-dominated system, to a very low productivity urchin barren condition. So going through these stressors again, just so that they're in your mind. This species of sea star, the Pycnopodia, the sunflower star, is the most voracious of urchin predators. It's been basically absent from our surveys for the last 3 years. We are seeing some other sea stars come back, but we're not necessarily seeing their feeding behavior on the urchins yet. And just a bit about timing. So I showed you guys that the kelp forest, we lost the kelp forest in 2014. This is some long-term temperature data that we have been monitoring subtidally, so in the kelp forest at depth, so not a offshore surface buoy, But this is the temperature that the kelp forest was, seeing. And in mid to late 2014, we had this huge spike in temperature. And that spike in temperature is not just thermally stressful, but it's also typically very low nutrients. We had a failure of bull kelp recruitment that year. And that has set us off on this, this train where it has created a food limitation in the system. And so this is just some a graph from a recent paper showing for our area in Northern California, just at what point do we get nutrient limitation, and that's around 12 degrees. So we were well above that temperature. So we got a bit of a double whammy against the bull kelp that year. So this is more like a timeline to kind of help put everything together for you, because there's a lot of complex pieces happening in close timing. This graph is the counts of, or the density of purple urchins over time in our area at multiple sites, and we can see that there's very low levels historically of purple urchins until we get to around a couple of years after our sea star mortalities, and then we start to see an increase. That might be due to a combination of increased recruitment because of warm water, because that happened about the same time. You can see the pink shaded bit where the warm water was hitting. There were reduced predation rates potentially because of the loss of the sea stars. There's a lot of confounding factors and difficult to tease that out. But what we do know is that whatever it was not enough to keep the purple urchin populations in a more balanced numbers for our system. And what those numbers look like, it can be overwhelming to count. They're not always this dense, but that's not unusual either in our area. The few bull kelp individuals that do make it through to grow to the surface are often being gnawed at their bases. So they will often, pick up an individual, and we'll see, oh, you're not actually attached. You're attached because the urchin that's hanging onto your base is attached to the ground. And here's a video from a couple of years ago. We've got the abalone that we're seeing are really starving as well. Normally you would see their tentacles sticking out, and there's just not any sub-canopy that we can see. This, like I said, this was a couple of years ago, so you're still seeing quite a lot of the pink crust in that previous video, but we're seeing quite a lot of areas where the urchins are grazing through the coralline crust as well. And also the abalone shells. That abalone shell should not be that shiny on the outside. Over the course of the last few years, we've gone from a recruitment failure of bull kelp, of the canopy, to a shift in the numbers and behavior of the purple urchin population to be much more aggressively grazing and impacting the sub-canopy kelps and other red algae in this system, to chewing through the crustose coralline on the reef as well. And recently we've been seeing them being, basically very desperate for any kind of food. We're seeing them eating sponges and jellyfish that are drifting by, and we can see them pigpiling on pretty much any organic matter. So this is some pretty extreme starvation conditions that have been persistent on our coast for coming on 5 years. I have to do the math every time I look. What year is this now? And that has had a huge consequence for the abalone, the red abalone, which we had the recreational fishery for. These are some data from some fishery-dependent surveys that we conduct during the spring. The orangish colors are the proportion of the abalone that we saw that the abalone fishermen were bringing into shore that were shrunken. Normally, the meat of the foot of the abalone will fill out the shell, and we've been seeing more and more of those being very small inside of a large shell. And it's very widespread. This is both Sonoma and Mendocino County. And it looked very similar 2016 and 2017. Following this survey in spring of 2017, when we were doing our subtitle surveys in the summer, we saw a lot of mortality, evidence of mortality of the abalone. Lots of empty shells everywhere, lots of actively dying or dead abalone that were being pig-piled on by the urchins. So we recommended to the Fish and Game Commission that they close the abalone fishery because of these incredibly devastating mortalities, natural mortalities that were environmentally induced. That was a huge loss for the coastal communities on the North Coast that are very small fishing communities and really rely on the tourism from more than 30,000 fishery participants for the red abalone recreational fishery. So there's huge consequences ecologically here. All of us in the room would agree with that. There's huge consequences for the human side of things too. And that is actually, I'll show you later, is actually helping to bring us together towards better solutions here. So we've had, more than 30,000 people who are really hit hard by the loss of the recreational red abalone fishery. We also have had a basically collapse of the red urchin fishery, which I showed you was, in the top 5 of our economic value fisheries in the state of California. This picture on the far side should, that's the inside of a red urchin. It should be bulging and orange, and it's totally empty. So there's lots of urchins out there, but they're all hungry, and they're not able to get enough food to create the reproductive tissue that we would target for a fishery. So I just told you this ecological horror story. And I think that it's easy to feel very, very down and very kind of fatalistic about, well, what can we do, and what's going to happen, and I think that is an ongoing challenge for for all of us who care very deeply about our systems as they are being impacted by various stressors. How do we deal with that? And I think that we deal with that by coming together and thinking outside the box and thinking creatively, recognizing what are the next steps we need to focus on, and rather than getting bogged down in the all of the big picture. But the very next step we need to think about is, how do we get the kelp back? Because if we don't have kelp, we have a totally different system. So is it going to be able to come back on its own? Do we need to help it out? what's going to happen if we don't help it out? What are the consequences of inaction versus action? Those are all really important questions, and ones that we are continuing to talk about. But just to answer this initial question, what's the likelihood of it coming back on its own? With the level of aggressive grazing pressure that we have on the bull kelp forest right now, it will be a really big challenge for the bull kelp to come back on its own, especially since it's been multiple years of very poor spore production. All of these early life history stages will be very vulnerable to that grazing pressure, and we might be not just in a system where we have huge numbers of urchins that are destructively grazing, but we may also be in a system that is very spore limited. So reducing the number of urchins might not be enough. We don't know the answer to that question, but that's a question we need to answer. So we have a few management challenges here. As I mentioned, if we want to have our kelp forest dependent fisheries to be thriving, we need kelp. And we don't know what the likelihood is that the kelp will come back on its own. We don't know what the likelihood is that we might have another marine heat wave or another El Nino, or there's a lot of unknowns. There's a lot of unknowns about the future. That's always the case, but it seems more the case now, right? But there's also a lot of unknowns about bull kelp population biology in Northern California. A lot of what we know is from Washington and Alaska and British Columbia. It's a very different system than our open ocean, open coast, further south, upwelling system, very different system than Puget Sound, where I'm from. So there's there's a lot of knowledge gaps that one of you guys could help us fill, I think. So, like I said, I think, what are the next steps? We have a need to come together. We have a need to recognize that we're all affected and that we all have something to contribute to this issue in terms of our expertise and our resources and our perspective on the world and our ability to relate to different people from different backgrounds to get them to care. So I started out by reaching out to the urchin divers in 2016 to say, hey, I'm seeing this thing, it looks bad. How does it feel for you guys? And they're like, yeah, it's bad. And so we started talking about what can we do. And from that has grown this larger partnership that we call KELPRR, and it's really focused on research. We've identified that we need to know answers to very specific questions to know the next steps that we're doing are responsible and effective. But we also think, how can we work together to think long-term about how do we enhance the resiliency of both our ecosystems and our communities, our human communities, against issues of climate change stressors. So I showed this actually at WSN. It made me so happy, this series of slides. This is the slide I showed at WSN in 2017 when I first started reaching out to the broader community beyond the urchin divers. Say, hey, let's all get together and let's chat. Let's figure out a strategy. I had quite a few partners then that I thought, okay, maybe we can add on to it. This is the one that we have this year. This makes me so happy. So the diversity of groups that have really come forward to contribute to the discussions and to the activities is really mind-blowing to me. We have resource agencies, both federal and state. We have nonprofits working with industry, with fishing industry and aquaculture industry, and tribes and academics. We've got marine and terrestrial industries. We've got a brew pub. We got all the good people, right? So, and each one of them brings something to the table, and a different way of looking at the world and at the problem and potential solutions. So I'm going to talk to you about what some of those solutions are that we've identified, and also some of the activities, what they bring to the table, how we all fit together into a cohesive group. Because it's easy to look at this and be like, that's a crazy amount of people that are from so many different backgrounds, and it's true. But there are a bunch of different people who are not used to working together. It's really cool to get them working together, and to trust each other, and to see that common goal and work for it. So, because of the scale of what we're facing, we have to have a different strategy rather than a brute force. We can just make this happen. We can just fix this instantly with some work, some good old elbow grease. We have to be a little bit more strategic about how we're going to do this, because we don't have unlimited resources, and I'm not sure that we can really, justify, putting so much effort into something we don't know is effective yet. So we're going to be doing some research, and we're going to be learning about how much effort it takes to do things on small scales, how effective we can be on small scales, and think about how we can grow and enhance that effect through maybe creating a network of small-scale efforts to increase spore production, and so that we're at least maintaining spore availability along the coast for when conditions might improve overall. That's our long-term, that's part of our long-term goal. And in the interim, that will help maintain pockets of healthy production of other species as well. So just to kind of introduce you to a little bit more of our partners, just to give you a flavor of what our activities have been in the last year especially. The Noyo Center for Marine Science is a small, fairly new nonprofit, small but mighty, I like to say, and they have really been taking the lead on reaching out to the community, engaging community volunteers, and not just their local Fort Bragg volunteers, but they set up this website with these two portals, the commercial diver portal and the recreational diver portal. So if you fit into one of those categories, you can click on that link and see all the different ways that you can get involved. And so the commercial divers, there was some grassroots fundraising that a couple of our partners did last year. They raised over $120,000 to support the commercial urchin divers to not target red urchins, but to target purple urchins from the Barrens in a coordinated, targeted way. We worked at out methods for being more efficient at harvesting purple urchins. It's slightly different. There's smaller urchins, and rather than only going after the largest, heaviest, most gravid urchins, they're doing a more inclusive sweep. So that was one of our activities last year that I'll tell more about in a bit. But the intention with that activity wasn't just to learn about how do we harvest purple urchins, but can we get some materials to work with to help develop a commercial market for them, a utilization for purple urchins that would help sustain this effort into the future. So this is some images of the commercial divers. They typically hand pick or with a rake. One of our divers has developed an airlift system to help get more of the smaller individuals out more efficiently. And last year, we worked at 3 sites in Mendocino County. They harvested more than 41 metric tons of purple urchins. And we estimated, based on our dockside sampling efforts, 1.2 million purple urchins. I'm pretty proud of them. It's a lot of effort. Most of those urchins went to a local compost facility in Ukiah, and recognizing the value of the calcium in the shell. So those urchins are, as I say, fairly empty of uni, but our land, our agricultural land, is notoriously low on calcium. And so having a sustainable source of calcium to add to compost is a really big deal. So this is a really nice merger of marine conservation and terrestrial land management and revitalization. There's another option that we're also exploring. I know some of you guys are probably involved in a pilot project here as well. There's a group called Urchinomics that have been partnering with San Diego State and with the Bodega Marine Lab more recently, and the Nature Conservancy, to explore ways of merging this kind of wild fishery concept and aquaculture concept so that we have more of a urchin ranching option, where we're taking empty, not valuable urchins from the Barrens, bringing them into an aquaculture facility, feeding them for a few weeks, 6 to 10 weeks depending, and then they are full and ready for market. And that is a live market, which is very different than the market that we would have with the typical wild fishery. So it's a more lucrative market. So that is a really exciting next step that we're exploring. Again, not thinking about one solution that's going to fix everything, but multiple solutions that in parallel can help chip away at this. So that's the commercial urchin harvesting efforts. We also were able to get a rule change by the Fish and Game Commission last year to increase the recreational harvest limit for Sonoma and Mendocino counties. For purple urchins, they used to be 35, and now you can get 40 gallons a day. So that opens up some opportunities. And one of our other partners, the Watermen's Alliance, which is a group of sport fishermen, is coordinating recreational harvest events. They're doing that every other month. They just had one last month, but they're planning the next one in May. I think it's going to be at Ocean Cove in Sonoma County, which is what this is, where they have like 40 to 100 divers show up over the course of a weekend. The low number was over this past winter when it was really stormy and nasty. They managed to get 40 people out there on a stormy Saturday morning. I was very impressed. But they have so far worked at 4 different sites. Some of them are coordinated with commercial harvest sites, and some of them are different sites. But they typically will get more than 2,000 gallons of purple urchins per weekend, which we estimate is, over the course of the last year, more than 200,000 urchins. So nothing to sneeze at, and gets a lot of people together and engaged in the issue and talking and learning. I'm out there and doing with my team and doing sampling of those urchins. We're cracking them open. They're learning about urchin biology. It's it's kind of a festival. It's kind of nice. And then this is a video of some of those recreational harvests. Many of them are free diving, some of them are scuba diving. It's a lot of work, but it's, you know, it's community building and really nice. And those canvas bags are really nice for getting urchins. Talking about community building and community engagement. Again, we have many opportunities for community science, whether it's at one of these recreational harvest events or dockside at the commercial harvesting up in Fort Bragg. I'm hoping we can get some harvesting happening in Sonoma County so we can get some opportunities in Bodega Bay as well. So, and when we get those urchins, we are tracking not just how much effort did it take to get them, how many did they get, but the sizes of those urchins, the condition of those urchins in terms of their how full of uni they are, what are they eating. We're getting a lot of important basic biological information and demographic information from them. So that's all great, but we also want to know the answer to what does this mean for the ecosystem? You know, what is all this effort? How is that affecting the ecosystem? Is the ecosystem responding? Is it sufficient effort to make sure that we get kelp patches growing? Since we've only been doing this for a season, we can't answer that question yet. we have to wait until next summer. But we have been doing monitoring. All these organizations on the bottom here all have various degrees of monitoring programs in the area, and we are able to pool our knowledge and our resources to ask those questions, you know, about whether are we, right now our question has been, can we tell how much of a reduction in density of urchins are we seeing in the sites where the commercial divers have been harvesting and where the recreational divers have been harvesting, and giving feedback to the fishers about, you know, whether we can see that or not. One of the things that that we noticed right away with the recreational harvesters after their first efforts, they were very spread out. They had some people working over here and some people working over there. Since then, they've coalesced and they've worked from a starting point, had a marker in the middle, and worked their way out, and that seems to be much more effective. So, you know, these are important feedbacks even before we get to our final answer that we're really aiming for. And I just wanted to put this out here again. This is, you know, our kind of a summary statistics from the Cal Fish and Wildlife surveys that occur on the North Coast. This is just from this last year's surveys. How much area total did we cover with our surveys? We almost covered 3 football fields, which is a lot of swimming. We counted over 200,000 urchins. And I want to point out this piece right here. A third of our divers are volunteers. And that's really important. And so I'm encouraging all of you divers to come out with us, because we have fun and we get lots of work done and it's fascinating. So that was my shameless plug. The next bit, you know, we need science and we need community engagement. We need those things to help us figure out how to move forward together. And so we've been working with the National Marine Sanctuary on creating an action plan. And an action plan that's based on a broad base of perspectives and sharing of our thoughts about what are the different needs of the different parts of the community, what are the resources that are available to us, what are these critical knowledge gaps. So we created a kelp recovery working group last year, which met for about 6 months, learned a lot about similar issues up and down the coast and from other parts of the world, because urchin barrens are not new, and we can learn things from each other. We will be releasing that at the Ocean Climate Summit coming up in San Francisco on the 18th of April. So, and abstracts are due tomorrow, if any of you want to join us at that meeting. And it's, I think, really relevant that it's being released at that Ocean Climate Summit, because really what we are talking about this issue in particular is a really strong example of what we would expect from climate change impacts to our systems. And I just wanted to put this up here. I'm not going to read it. There's a lot. This is all the information from the IPCC report on what types of things we might expect from climate change. And basically increasing frequency and magnitude of impacts and multiple stressors. And so we would expect variable effects over latitude and altitude. We expect that these stressors are going to hit at large scales, way bigger than one site, but coast-wide, which is what we're seeing. And we expect them to be happening concurrently and interacting in unpredictable ways. So, or unpredicted ways. Hopefully we can predict them at some point. But I think we can learn a lot from these examples that we have about how do we better understand the potential interactions of those multiple stressors, and how do we respond as a community to help mitigate the consequences of those in the future. And just to finish up, we really need to think creatively and use the science to help us expand that creativity of thought. And we really can't, I think, from my perspective, move forward as a society dealing with really just thinking about ecological consequences and not bringing in the social aspect of it. So thank you very much for your attention, and I'll take any questions. Are we feeding them before they got to reproductive enough for marketable size? Just to clarify, that was not my work, but our partner's work at San Diego State, Renee Angwin, and we will be recreating, reproducing that a similar design of work up in Northern California, because the purple urchin populations are very different, have different stressors and different environmental conditions that they are living in. There might be some very different things happening there. But to answer your question, there was some really promising